Hey, I'm here with Cindy Evans in the HDU. How are you?
Fine, thanks.
Thank you so much for having us.
Yeah, welcome to the HDU.
This is really, really cool. Tell me a little bit about you and what you're doing with the HDU.
Okay. Well, I'm a scientist at the Johnson Space Center, and there's a core of scientists there, including people who supported the Apollo missions. And one of the things that we're trying to do is work out new science operations for conducting geological traverses on other planetary surfaces, the Moon, Mars, near-Earth objects.
Sure.
So the rovers are out doing their traverses every single day. They're collecting a lot of samples. And when they come and they dock to the HDU,
Yes.
we know they're going to collect more samples than they can bring back home. We know there's going to be some really tough decisions that the science team is going to have to make in order to bring samples back home.
Right.
So we designed this laboratory to help do some preliminary examination of the samples so that the scientists have more information so they can make those decisions. They can prioritize samples, they can know a little bit more about what they might be bringing home.
Gotcha.
So this is the GeoLab. It's designed after the curation glove boxes that we have at the Johnson Space Center for the moon rocks.
Okay.
But we had to make some modifications. We had to fit into our little pie slice, and so it's got a real funny shape. It's a trapezoidal shape.
Lots of room here.
Lots of room. So the big thing is that we've got these little antechambers, 3 of them, 1, 2, 3.
Okay.
They're like little mini airlocks,
Okay.
and they punch through. Actually, on this outside camera, you can see where they come through on the outside.
Oh, this is what we saw from the outside.
That's exactly right. That little back porch there.
Okay.
So
Yeah.
our crew members, they're going to, when they dock to the HDU, we're going to ask them to go out in EVA, get specific samples that they may want to analyze.
Sure.
They're going to open up those little one of those little mini airlocks. One's an inbox, and then once they've transferred, the person on the inside in a nice, comfortable shirt sleeve environment can retrieve those samples. And oh, we got a mail delivery.
Look at this.
Look at that. So we have an inbox, we have an outbox.
Okay.
Okay. So when we get the sample inside, then we have a mass balance. I should put these back on. We have a mass balance where we can weigh the sample.
Right.
We can take measurements of the sample. We can photograph the sample with these overhead cameras, and then we can put the sample on this stand right here. This is a microscope, and then I just acquired an image. And then we can put a little scale bar on that image, and it's saved as an image file that the science back room can actually drag over and look at. So that the crew members, they'll be talking to them and saying, well, look at, I see these really cool crystals, and the science team may direct them to look at a different place.
So here's a question. I mean, why do we have to study these rocks from other planetary surfaces?
Well, one thing that rocks from other planetary surfaces tell us is something about how the solar system was formed. We have rocks on the Earth. We understand a lot about rocks on the Earth. We have just a small number of rocks from the Moon. We have no rocks from Mars except for some meteorites. We need to have those rocks, look at them, understand their chemistry, understand their forms, be able to say something about the solar system formation.
Cindy, thank you so much for having us in the HDU today.
It was a pleasure.
It was awesome. Hey, this is NASA 360. We'll be right back.